Okay, welcome to this three-part question on linear graphs. Okay, so we've got a bit of everything in this question. We're starting with 2 points A and B, and we're given that a line L goes through those 2 points. And we've got to find an equation for that line. So let's do that first. Now, the gradient of L is basically made up of the difference in y coordinates divided by the difference in x coordinates. Okay, so I'm just going to write that up here. The gradient of L, okay, the gradient, because we need the gradient to find the equation. So the gradient of L is equal to, now it's the change in y divided by the change in x. So it's 5 take away minus 3. Okay, 5 take away negative 3, which is the same as 5 plus 3, and that has to be divided by the change in x, which is 7 take away 1. Okay, 7 take away 1. Now, that comes to 8 over 6. Okay, and 8 over 6 is the same as 4/3. Okay, so I'm just going to write here 8 over 6. Okay, and 8 over 6 is also equal to 4/3. Okay, so that means that the line is, for every 3 I go across, I go up 4, which looks roughly correct on my sketch, which is approximately to scale. Okay, so the equation of line L, the equation, so if I put here question A, the line L, right, the equation is of the form y equals 4/3 of x, that's the gradient, plus some number c, where it cuts the y-axis. Now we're looking at this here and we can see roughly where c is, but we don't know what number that is till we work it out. But we know one point on the line. We know 2 points on the line. We know the point A and the point B. And we can use that, one of those points, to find what this value of c is. So we could say at the point, okay, 7,5, let's take point B, okay, at 7,5, right, we have that x equals 7, you see, that's the x coordinate, and the y coordinate, when x is 7, y equals 5, you see. So instead of using y and x in this equation, I can use 5 and 7. So I can say that 5 equals 4/3 of 7, that's 4/3 times 7, okay, plus this number c. And we can then use that to find out what c is. Now, if you times everything by 3, in fact, what I'll do first is I'll times this out. So this is 28 over 3. Okay, so I could say that 5 minus 28/3, okay, is equal to c. Okay, and 28/3 and 5 is 15/3, you see. 15/3 minus 28/3, okay, would give me that c is minus 13/3. Okay, there's no reason why you couldn't put that on a calculator to save time, but it's fairly easy to work out that c is minus 13/3, which is just minus 4 1/3. So this point here, where it crosses the y-axis, is at minus 4 1/3 or minus 13/3. So the equation of L, is, so equation for L is y equals 4/3 x minus 13/3. because that's what the question wanted us to find. Okay, so that's question A completed. Now in question B, it's asking us about a different line. It's called the line M, and it has this equation. Now I'm just going to rearrange it so M could be written in a slightly different form, and that's to subtract the y from both sides, subtract the 4x from both sides and add the 17. So I could write it as y equals minus 4x plus 17. Okay, and that tells me that the line M has a gradient of -4 and it cuts the y-axis at 17. So it looks something like this. Let me do this in a different colour. So 8, 10, 12, 14, 16, 17, it's about there, right? It's coming through here and it's coming down with a gradient of -4. But I also know it's crossing, because if I read the rest of the question, it says I've got to show that C is the midpoint of AB. So I can make it do that now in my sketch. So that place where it crosses the line L is roughly halfway between A and B. All right, so I'll just extend it a bit further. Okay, like that. So that's the line they're calling line M. All right, it's crossing here at 17. Okay, and this point C is halfway between A and B. Okay, and we can work out what C is by looking at the difference, the midpoint between the x's and the y's here. Okay, but we're going to find it algebraically as follows. So what we're going to do next is we're going to say that at C, okay, at C, the point C, then the two lines cross and they have the same x and y coordinates at that point C. So what we do is we relate this y here to this y here, and we set the two things equal to each other. So at the point C, we can say that minus 4x plus 17, which is y, must also equal this y, which is 4/3 x minus 13/3. Okay, and we have an equation now that just contains x, so we can find out what x is. If I just times everything in there by 3, that will clear the fractions for me. So I'm going to write it as minus 12x plus 51, okay, 3 times 17. That gives me 4x minus 13. No fractions to worry about. Now, if I put all the x terms on the right by adding 12x to both sides, that will give me 16x, okay? And if I add 13 to both sides, it will give me 64 when I add that to the 51. Well, if 64 is 16x, then it means that x must equal 4, okay? And if x equals 4, I can sub 4 into the equation, substitute 4 equals x into the equation for m, into the equation for m, or indeed any of the equations above, but I'm going to use this one here. Okay, so I can do it like this. I can say that y equals, so that implies that y equals minus 4 times x, which is 4, okay, plus 17. Okay, which is minus 16 plus 17, which equals 1. All right. So when x is 4, y is 1. So therefore, C is the point. Let me just, so that equals 1. And therefore, C is the point with coordinates x equals 4 and y equals 1. All right. Now, we've got to show that C is the midpoint. Now, we can kind of see that it is, but I'm just going to show you how we can mathematically show it, that it's the same, that it's the midpoint between A and B. Okay, it's halfway between 7 and 1 is 4. You see, it's the average of the two x coordinates. And then we can say that C, I'll go up here for this part, or just here actually. So C is actually the same as 7, so it's the midpoint of these, so it's 7 plus 1 over 2, 1 plus 7 over 2, okay, comma, and then it's the average of the y coordinates, which is 5 plus minus 3, okay, over 2 as well. Okay, and if you do work that out, you will see that that comes to 4, 1, which is, we know, the same as what we've just found here. So we've shown that C is the midpoint of AB, and it's also where the line M crosses the line L. So C, which is equal to midpoint AB. Okay, we'll just write that there to summarize it, midpoint AB. Okay, now we've got one more part of the question to do, and this is part C. If I just partition that off there like that. So part C of the question over here now is asking us to show that the straight line perpendicular to M, which passes through the point C, also passes through the origin. So what they're saying here is if I did a line at 90 degrees to M, then if it goes through C, it should also go through O, the origin. So let's see if it does. Well, from the sketch, it looks pretty close. And I think you'll find that if you were drawing it accurately, then it would show that that was making a right angle in there. Now, it doesn't quite look right from the sketch, but we wouldn't expect it to. But we'll show it as a right angle because that's what we're expecting to find. Okay, and we got to show that it goes through the origin, which is the point 0, 0. So what I'm going to do here is I'm going to say what's the equation of the line perpendicular to M. So equation, so this is part C, equation, so part C, equation of line perpendicular to M through C. Okay, well, it's going to have a gradient of a quarter, okay, because a quarter is 1 over 4, 1 over negative 4, and it's the negative of it. So the gradient of this is minus 4. The gradient of this line that crosses it at 90 degrees is plus a quarter. So y equals a quarter x plus some number. I'm going to call it d because we've used c already over here, okay, to find the constant here, up here. All right. Now, we know that at a certain point that's on the line, we know that at C, okay, x equals 4 and y equals 1, because that's the coordinates of it. Okay? So therefore, using this equation, okay, we can say that a quarter of 4 plus d equals y. Let's put the y in front. Y was 1. So 1 equals a quarter of 4 plus d. Okay? Well, a quarter of 4 is 1. Okay? So 1 equals 1 plus d. Well, for that to be true, that means d must be 0. Okay? And that means the equation of the line is y equals a quarter x plus 0. But the plus 0 tells you that the line crosses the y-axis at 0. So it's got a gradient of a quarter and it crosses at 0, which means it goes through the origin here. Because if it was crossing at 1 or 2, it would be up here somewhere. But it's not, it's crossing at 0. Which implies that y equals a quarter x and goes through the origin and goes through O. Okay, and O is the origin. Okay, so that's a really interesting little question. Lots of things going on there. Parallel lines not mentioned, but perpendicular lines are, and solving to find the point where lines intersect. A diagram or graph is always helpful to visualize this kind of problem. Okay, I hope that all made sense. Take care.